So hello students, today we are going to start the past paper for the graph of functions. Let us see the first problem. The graph of y equal to f of x is drawn on the grid. It had already been drawn here. So what we are looking for? We are looking for draw the tangents to the curve at y equal to f of x. So draw a tangent to the curve at y equal to f of x at x equals to 2.5. So first of all, what we are looking at, we are looking where is x equals to 2.5 located. So on x axis, on the x-axis, and this is 2 and 3, it means this is going to be 2.5. So here we are having exactly here we are having x equals to 2.5. Okay, so we have to draw a tangent here, and let me try to draw a tangent with the tool. Okay, I'm using the tool, so sometimes it takes a little time. Kindly pardon me. Approximately. Okay, here, approximately here. I think that is perfect. So that is the tangent which had been drawn at x equals to 2.5. Okay, so the first problem is solved here. This had been done. So what is the second thing? Second thing we have been asked here to use your tangent to estimate the gradient of the curve at x equals to 2.5. So because we have made the like a tangent here, and we need to find the gradient. So to find the gradient, what kind of formula we always use? Gradient of a line or anything is change in y with respect to change in x. Okay, rise over run. In the sense, we can write it as rise over run. So sometimes rise over run is not feasible on the graphs, so hence finding a coordinates of the point is quite easy. So let us take those points who has these 2 points as x coordinates. So then our calculation is going to be easy. Then if you look at this point is y is, so first of all you need to have the scale here. So y as y axis, what is the scale? One big box had been divided into how many parts? 10 parts. 10 parts, it is 0.1. It means one small box is equals to 0.1. So you need to be very careful on this, because sometimes if you see here, x-axis has 1, 0 to 1, 10 boxes, but on x-axis you will say 0 to 1 has 20 boxes. So hence the difference is very, very important. And the scale on x-axis, one unit had been divided into 20 boxes. So hence the 0.5, so one small box is equals to 0.5. You can use your calculator to count the boxes. When there are 10 boxes, it is very very easy. So this is 10, and if you go upwards from here, then 15, 16, 17, 18, 19. So x is 3 and y is 1.9. And you can find the other point here approximately. So here x is 2 and y 1, 2, 3, 2.2 comma 0.3, because it is less than 1. Okay, so we found the 2 point here, and we'll substitute the values like what we have given, that y is 1.9 and here y, let us write here to make you convenient. Okay, so y1, and this will be taken as x2, and this is going to be taken as x1. So 10, so y2 minus y1, 1.9 minus 0.3, and on the other hand, x is 3 minus 1, so hence the answer is 1.6. So hence the gradient is going to be 1.6. When you are estimating the gradient of these kind of problems, there is a range of answers. If I try to find what is written in the marking scheme. So marking scheme gives us the range from 1.55 to 2.2. So your answer can be anything between these two, all will be accepted. Because when you are drawing the tangent with your scale and pencil, it is not necessary that every student is going to make the same tangent. There may be a slight variation in the tangents. Okay. So on the other hand, that is done. Let us find the other question. The B part, use the graph to solve f of x equals to 2. So f of x means the graph, and we let f of x as, because what we have here, we are having here f of x equal to y. So what we are going to do here, we put f of x equals to y, and we are having y equals to 2. So what is y equals to? On the Cartesian plane, on the graph, y equals to 2 is a horizontal line. Okay, horizontal line at y equals to 2. It means like this. So if this is point 2, then this is going to be our graph. That is the basic idea that I'm trying to give you. And solutions means where the graph cuts, graph of y equals to 2 cuts the original graph, what had been given in the beginning. Okay, so that is the whole job which we have to do. Y equals to 2 is a horizontal line, very easy to draw. Let us draw this. Y equals to 2. I'll try to take a blue pen to draw this. Okay, this had been drawn and it can be lifted little upwards. Let me try if I could do it. I think that is perfect. Okay, so this is y equals to 2. We have to write here what line is representing y equals to 2. So this is graph of y equals to 2. And y equal to 2 intersecting the original graph at 2 points. Let us take one here. Okay, this is the first point and this is the second point. So when we are solving with the equation, with the help of an equation, so we need to find the x values. So let us try to draw. Let us try to draw this thing like, okay, approximately here. And when we are looking for the other point, we are looking for the x coordinates approximately here. So we have to look out what are the coordinates. See, it is very difficult to understand because on the x-axis, one small box is equal to 0.5. You need to count this, okay? So here we are having 1, 2, 3, 4, 5, 6, 7, 8, 9 divisions. So hence it is going to be 1.45 because 9 times 0.5 is 0.45, and what we are having here, 1, we are 1 ahead. Okay, so 1.45, and the other point it is having 2.5 plus 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6 small boxes ahead 2.5. So 6 into 0.5, I am ahead 0.3. So 2.5 plus 0.3. So here exactly I am at 2.8. Okay, it means the coordinates of this is 1.545, comma 2, and here the coordinates are 2.8, comma 2. So these x values are going to be the solution for the required graph. Okay, so we'll write here 1.45 and 2.8. That is the only thing which we need to draw. So the B part is already solved. Let us move further. What is happening? So part number C, what it says, there is a new function introduced, g of x equals to x by 2 plus 2 by x square, where x is not equal to 0. Why this constraint? Because here we are having x in the denominator, and if you put 0 here, then function will be not defined. So division by 0 is not defined. So hence we have to give the constraint here when we are having denominators, x. Okay, so in that sense, complete the table of values of g of x corrected to one decimal place. So you need to very much aware about what are the conditions given here. Corrected to one decimal place means if your answer is like 2, 3, 4, 5, 6, 7 on the on the screen of the calculator, then you have to give your answer only to one decimal place, and this digit would be rounded off. Okay, sometimes it can be rounded up, sometimes it can be rounded down. It depends the value of this number. If this number lies between like 0 to 4, then it is rounded down, and if it is 5 to 9, then it is rounded up. Okay, fair enough. So let us remove this. I know you are very well aware about it, and we need to find these values. So here the calculator comes into the picture. So there are two options with you. One by one, you put these values 1, 2, 3, 4, 5, 6 times. Sometimes here are only 3 values. So you can use a calculator, and calculator has a function of table. So if you use that function, you can fill all of the table by using the calculator without even substituting a single value here. So what we need to do, there is one constraint for the calculator when you are looking for the table. That constraint says the gap between the numbers mean x values, the x values should be same. Like 0.7 to 1 and 1 to you are moving to 2, then this is not acceptable. So what we need to do, we will find the value of 0.7 by substituting here, and now we will learn how to use these two values without even substituting. Okay, so let us try with the calculator. Here is the calculator. Let us try to put the values. And what we are having here, fraction plus one more fraction. Plus one more fraction. Okay. So what is happening here? 0.7, 2 over 0.7 square. And on the first thing, because we are substituting x, the x is 0.7 upon this is 2. Okay, this is 2. So upon 2. And let us give the check, and we are having here the answer is 4.431. So we will write here the answer is 4.431 because we have to submit the answer up to one decimal place. So therefore it would be rounded down and the value will be taken as 4.4. Okay, that was the odd kind of number. This doesn't form any pattern, so we have to find this number in an individual manner. Now what we'll do, we'll try to find these values without substituting. Okay, let us go to the calculator again and try to see how to do it. So you need to go to the mode and you need to find in your calculator what number gives you the table function. In my calculator that is 7. So press 7. Now we have to put the function here. Okay, so function is x. So how you will enter x here? Use this button. Sometimes it is shift, sometimes it is alpha. So alpha, it is x. Okay, to get the x here. So we will put a fraction and we are having x. X would be something alpha and then this bracket button. And here we are having 2. Then plus again a fraction, that is 2 over, we need to have x again, alpha and this bracket end, and we need to put square. Okay, so function had been distributed here. Now we need to press the equals to button. Done. There is no second function. Go to start, where your values are going to be started. Your values are going to be started at x equals to 1. Okay, so this is start is 1. Enter. Where it is going to end? Your value is going to end at 2. So what we'll do, we'll put here 2. Do not do anything with 5. Okay, put 2 here. Enter. Now what is the gap between? So what is the gap between 1 and 2? That is a gap of 1. What is the gap between 2 and 3? That is going to be 3. Okay, so let us put gap as 1 itself and done. So you got the value. At 1 you are going to get 2.5. At 2 you are going to get 1.5. So that is the perfect answer which we have got here. So 2.5, and what is the other answer? That is 1.5. So that is how you can use your calculator. If there are many values, then this table function is going to help you a lot. Okay, so what do you need to do? On the grid opposite, draw graph of y equals to gx. So this function's graph we have to draw on the grid given. Okay, so let us move further. The x value starts from 0.7 and they are ending at 3. So we'll go to the graph and put those values. So first value, I'll write some values here to make myself a bit convenient, or I can take the screenshot for this table. Okay, so let us go to the graph here, and I'm going to take these values anywhere here. Okay, so that's not being copied. 0.7 and 4.4. X 0.7. See, there is a problem here. When we are putting x 0.7, 0.7 means how many boxes here? Like it is 20 boxes and one small box is giving equal to 0.5. So if you are looking for 0.7, divide by 0.5. You need to divide that. So 0.7 we have to get the mode and calculator 1. So 0.7 divide by 0.2. 0.5, sorry, 0.05. There are 14 small boxes. That's, I made a mistake here, I think. It is 0.5. Okay, we are looking at x-axis. One box is 20 boxes, one unit is 20 boxes. So in 0.7 is 14 boxes. So this is 0.5. This is going to be 0.6. This is going to be 0.7. So one thing is 0.7 and the y is 4.4. Okay, 4.4 is easy because there's a one box is equal to 10 small boxes. So we'll rise up here. .4, that is exactly here. So we got this thing, and I'm going to draw this with let us assume pink color. 4.4. This is going to be our point. Okay, first point 0.7, 4.4, and what is the next thing? Next thing is it is 1 and 2.5. So 1 and 2.5, that is easy to plot. That is 1 and it is ranging towards 2.5. So it is exactly here. So this is our second point, and I'm going to delete these vertical lines to avoid any kind of confusion. And the third point is 1.5 and 1.6. Okay, 1.5. So this dark line represents 1.5 and go vertical till 1.5, 1.6. Okay, so 1.5, this dark line, and 1.6, that comes out to be exactly here. Okay, so this is representing 1.5 and 1.6. So the x values are horizontal values and y values are vertical values. We put the three values here and let us see further what is happening. 2 and 1.5. So we need to draw 2 and 1.5. This is approximately here. 2 and 1.5, and further the value is 2.5 and 1.6. So 2.5 is here. This is 2.5 and 1.6. 1.5. Let me delete this. 1.5 and this is going to be 1.6. This value. Okay, and furthermore we are looking for 2.5. That's done. 3 and 1.7. Let us go to 3 and 1.7. 3 and 1.7. This is 3 and 1.5, 1.6 and 1.3 and 1.9. So these are the points which have been given here. and we need to connect these points to perform the graph. Okay, I'm trying to do with my device, and let me see how I make it. So my graph is not that much accurate, but if we are drawing with a pencil and scale, I think we can obtain some good value here. Okay, so this is the graph which we have drawn here, and now on the grid, draw the graph. Part number 1 is done, part number 2 is done. Solve f of x equals to g of x, and we need to find different values. Okay, so let us see where our graph intersects with the original graph which we have been looking for. The graph is intersecting at 3 different points, and let us see what is happening. The first point is, what we need to do, we need to go to the graph and try to find those points here. That is the point, and we need to go directly to x-axis from this point. Let us see where it leads. Exactly here, and it is 0, 20 boxes, this is 18, and it is going to be, hence it is going to be 0.9. The first x value is 0.9. Let us note down here 0.9, and the second x value is where the graph is cutting. The graph is cutting here. Okay, this point, and let us go down and try to find what is exactly it is. It is 1.5 plus 1, 2, 3. So 1.5, it is going to be 1.65. So this point is 1.65. Let us write it down, 1.65. And the third point, it is cutting the graph over here. This here is the third intersection. And what are the coordinates? Let us count the boxes here. This is here exactly. So this is 5, 2.6, 2.7, and approximately it is 2.7. Okay, so the x coordinate here on this point is approximately 2.7. So let us take these 3 points and let us give our answer 0.9, 0.9 here, and the second value was 1.65 and 2.7. 1.65 and 2.7. So whatever answer I got, your answer may be little varying. So you need to go to the marking scheme, and the marking scheme gives you the range for the first number is like 0.75 to 0.9, and this number the marking scheme is giving 1.6 to 1.7, and for this point the answer is varying between 2.6 to 2.7. So hence we got all the answers in between the given range. So that is how we deal with the problem of the graphs. Let us see one more question here for the graphs itself here. Okay, so the table shows some values for y equals to 3 by x cube, 3 by 10x cube minus 2x for some certain values of x. So we have to first of all complete the table, and we are going to get 3 marks for this table because a lot of values have to be substituted. So you need to look at which kind of values we are missing. That is minus 3, minus 2, minus 1, then 0, then 1, then 2, and then 3. So these are the values which we have been provided to find it out. So hence they are having all the gaps of 1. So we can bring our calculator table to solve this kind of problem. So graph is completing the table. It is a petty job if you are having the points which are having the same gap. So let us put to the mode and look at the table. In your calculator it may be a different number, but in my it is 7, and put 7. So first of all we need to enter the function here. The first thing is y equals to 3 over 10 x cube. So first of all 3 over 10 x cube, that is x we get to alpha and this bracket, okay, x cube, and we need to raise the power 3. Done. And further we are having minus 2x, so minus 2, and for call x alpha and this bracket. So you enter the function, put equals to button, and then start. It is starting from minus 3, plug in minus 3 here, enter, and it is ending at 3. Okay, fair enough. Put 3 here. Do not worry for whatever number is written here. Okay, so 3, and what is the gap between the boxes? Minus 3 to minus 2, 1 unit, and again 1, again 1. So step is 1. How much you are jumping? So we're jumping 1 unit, and here we go. So we got at minus 3 we are having minus 2.1. Okay, at minus 2 we are having 1.6. Okay, at minus 1 it is 1.7, so hence we can verify also. And on 0 it is 0. Okay, let us see further. We have to put this down button. On 0 we are having 0, this is tallying, and on 1 we are having minus 1.7. Fair enough. And let us move further. On 2 it is giving us minus 1.6. See here, minus 1.6 is fair. And on 3 we have to put the down button here again. On 3 we are cutting 2.1. So these are the points which have been given, and we have solved this 3-mark problem in a minute itself. Okay, fair enough. So on the grid, draw the graph. So when we are drawing the graph, you need to be very careful about the scale. You need to count if one box is equals to 1 unit, 10 small division is equal to 1 unit. It is very easy graph. So we do not need to worry about the scale. So on the x-axis, on the y-axis, 1 unit is equal to 10 small units. So hence it is very easy. Let us draw. The first point is minus 3 and minus 2.1. Minus 3 is here and minus 2.1. We go upwards. This is 2. Minus 2.1, we go to downwards. Okay, minus 2.1. So this point is here. Okay, minus 2 and 1.6. So here is minus 2 and 1.6. We go to upwards and we'll find this as this point. Okay, done. So that this is plotted, minus 1.5 and 2. You need to carefully see the signs, okay? Minus 1.5 here and 2. We are going upwards. We are going upwards here. So this is the exact point where we can find minus 1.5 and 2. Then minus 1 and 1.7. This is minus 1 and we are going to go 1.7, 5, 6 and 7 here. Here we find the next point, and what we are looking for next. This is done, 0, 0. So hence everybody knows this is the origin itself. 1 and minus 1.7. So x is 1 here, and for minus 1.7 we have to go a little down. So this is 1, 1.5, 1, 2, and this is the thing. Okay, fair enough. And the last one, not last one, the least 1.5 and minus 2.0. 1.5 is here and minus 2.0, this is exactly here. Okay, so we have plotted this thing also, and 2 minus 1.6. 2 minus 1.6, that is 2, and let us assume 1.6, that is 1.5, 1.6, 1.7. Okay, so 1.5, 6, 7, we are approximately here. Okay, fair enough. And the last thing, what we are looking at, 3, 2.1. So x3 by 2.1 is approximately here. So these are all the points which we have plotted, and before plotting it once you need to verify it because it is going to give you 3 marks. So one mistake is going to cancel all of the comprehensive problem. So minus 3 and minus 2.1, minus 2, 1.6 and minus 1.5 here done, and let me delete it simultaneously. Minus 1.5 here, and then 2, that is also correct, minus 1 and 1.7, done, 0 comma 0, 1 and minus 1.7, that is also 6 and 7. Okay, fair enough. So all the points have been verified, and we need to draw in such a manner. Okay, so this is the graph which we had obtained here. My graph is I'm trying to draw with the tool, so there is a very less accuracy, I think, but I hope it is going to work. Okay, so what is the problem here further? We have already obtained 3 and 4, 7 marks here. Let us go further. On the grid opposite, draw a suitable line to solve the equation this and that. So first of all, we need to copy the function. The function is y equal to 3 by 10 x cube minus 2x. The function is y equals to 3 by 10 x cube minus 2x. Okay, so what we are looking at? We are looking at this equation. This says, when you are solving these kind of equations, what you need to do? When you are looking at the straight line, you need to make the left hand side of the equation, you need to match with original function. You need to match with original function. For that, you need to be like adding something both sides, or you will be subtracting something both sides. You need to do a lot of activities. But here in this problem, if you see left hand side of this thing is exactly same as the function itself. Okay, so when it is exactly same, you need to do nothing, just replace this thing with y, and you are having the equation as y equals to half 1 minus x. Okay, so here what you need to do, you need to draw a suitable line. So I already told you that when you are having y equals to something, you are having horizontal line. When you are having x equal to something, you are having vertical line. But when you are having equation in the form of y equal to mx plus c, in that equation the line is going to be slanting. The line is going to be slanting. Okay, slanting, it means the line would be like this or this. So hence we need to find 3 different points or coordinates. So we have to draw here a small box, and let us find different values of x and y. We need to find at least 3 values. Okay, so if we put here x equals to 0, let us try with something else. If I put x equals to 0, what is going to happen here? X equal to 0, that is going to be 1 in the bracket, and 1 divided by 1 by 2, that is going to be y is 0.5. So when x equals to 0, y is equal to 0.5. Okay, the second value you can take as x equals to 1. If we take x equals to 1, what is going to happen here? 1 minus 1, 0. 0 into half is going to be 0. So y is going to be 0. And we can find the third value to make yourself very much sure. Then if you put x equals to 2, let us assume, then we are having minus 1 here, and x equals to 2, we are having minus 1. 1 minus 2 is minus 1. Minus 1 divided by 2, it is minus y equal to minus 0.5. Minus 0.5. So we got 3 points here. We need to plot these 3 points on the graph itself. One is 0, 0.5. So x is 0 and y is 0.5. This point is exactly here. 0 and 0.5. If my calculations are correct, then 1, 0, x is 1 and y is 0, hence we lie here itself. So this is 1, 0, and the third point says I am 2, we are having 2, minus 0.5. So x is 2 and minus 0.5 we have to go down here. So hence this point lies here, exactly here. Okay, so we have plotted the 3 points, and 3 points, they are looking in order in a line. So hence I think my graph is going to be very much correct. So let me draw, and I have to take a lot of effort here to make a straight line if the tool gives me permission. Okay, we are through here. Okay, very good. So this is the approximation which we have drawn, and let us see, we have to find what was the question here. Let us read again. The question says, on the grid opposite, draw a suitable line to solve the equation. So we have to solve this equation and we have to find the values of x. Okay, so the graph is intersecting at 3 different points. This is the first point, and let us go down. The value of minus 2, and the graph is intersecting approximately here. The value here is 1.5 minus 1 point. This is 1, 2, 3, 4. This is minus 0.4. This is the second value, and here we got the third value, x value approximately here, and we go here. So this value is approximately 2.2. So this is the third value. So minus 2, 0.4 negative, and 2.2. Let us see how it works. This is minus 2, and moreover it is minus 0.4, and further we are having here the graph is intersecting, the line is intersecting here, and this is 2.2. This is 2.2. So in this way we have solved this thing. So now what the question is asking for this graph equals to 1 has n solutions. Now find the value of n. So this is like when you are looking at this kind of equation, first of all, always look at the left hand side. It should be identical to the given graph. If it is not, then you have to make some modifications here. So let this thing as y equals to 1. So what is y equal to 1? That is a horizontal line. So we have to draw y equal to 1 as a horizontal line. So we do not need to draw here, we can just guess. So if we are drawing y equal to 1 here, then on how many points it is cutting the graph itself? It is cutting the graph at 1 point, second point, and third point. It is cutting the graph at 3 points. So we do not need to draw this, okay? I'm just giving you an idea how to look at. Okay? So the graph is being cut at, if I draw a function here, then it is going to cut at 3 points. So hence it is going to have 3 solutions. So that is the problem number 2. Let us move to the next problem. Okay, that is something big, but it is a cubic graph. Let us see what we need to do. 3 marks for the completion of the table. So if you are substituting the value one by one, you are going to kill a lot of time, and there may be heavy mistakes which you can make. One thing you need to make very sure, if you are putting minus 3 in the value of x, if you are doing it cube, then you are going to get minus 27. Okay, but if you are having, let us assume 4 power, then you are going to get minus 81. So this should not be done. When you are putting the negative value in the graph, the negative value should be kept in the bracket, because this 4 power goes to minus 3 and this 4 power goes to minus 3 and 3 both. So hence the answer should be 81, because when we have even power, the answer we get a positive answer. When we have odd power on us in the bracket, odd power, then we get negative answer. You need to be very careful, okay? So I am not going to use each and every value and put in the plugin and waste a lot of time. Let us see what values we are missing. Minus 3, -2, -1, 0 and 1. So the values which are missing, they are at the count of 1. So hence we can use the calculator table to frame this. Okay. Already table function had been already opened here. So let us try to put those values. We are having x cube. So x, and how you bring x here? So alpha and this and bracket, x cube raised to the power 3. Okay, fair enough. Then plus 3 alpha x to the power 2, it means square, and then again plus, then 2. Okay, fair enough, equals to, skip this, start number is -3, so I'll substitute here -3, done, and okay, then it is ending at 1. Ending at 1, and what is the step, what is the jump in each number? That is 1 unit. Okay, done. So we got the table here. So these are the x values and these are the output y values or f of x values. So at -3 we are having 2 here. Where is the tool? Okay. We are having 2 here. At -2 we are going to have 6. See, this is correct. And on 0 we have to put this down button here. On 0 we are having 2. And on 1 we are having 6. Okay, so those are all of the values we have completed within a minute. Because I am teaching you, it may take a little time for me, but when you are practicing, it is not going to take much time. This is a most significant job when you are drawing the graph. Okay, if you made a mistake here, then you are going to lose a lot of numbers. So this is 3, this is 4, this is 1, this is 2, this is 1. All of the numbers are going to be snatched away from you. Okay, let us draw the graph. So first value is x minus 3.5 and second value is y minus 4.1. So first of all, you need to look at the grid and see the gaps. What is the scale here? If you look carefully, what is the scale here? It is a little complicated. Let us see how to handle this. Okay, the first thing is, first of all, you need to count this on x-axis. What is happening on x-axis? One box is divided into 10 small parts. It means one small part, one small box equal to 0.1. That is fair. That is very simple and normal. But when we are going on the y-axis, so what we are having here, these 5 units have been divided into 10 small boxes. So on y-axis, so 5 units have been divided into 10. It means 0.5. It means one small box is equals to 0.5 units. So if you see an odd distribution here, you need to find the value of each small box every time. That is very essential. So if you did not understand the grid, then there is no chance you are going to plot these numbers correctly. So first thing is 3.5 and minus 4.1. So 3.5 is clearly visible here, that is 3.15 and minus 4.1. So for minus 4.1 we have to go down. So on the y-axis, one small box is 0.5, we are having minus 4.1. Okay, let me see how I use calculator for this. So 4.1 divided by 0.5. So what we got? We got 8.2. So we have to find 8.2 boxes. This minus, so this is 10, this is 9, this is 8, and this is going to be approximately here. Okay, so this is 10, this is 9, this is 8, approximately here. So first point I have plotted here, and what is the second one? Minus 3, 2. So minus 3 is clearly visible here, and 2. So 2 we have to divide, 2 divided by 0.5. So you have to use the calculator every time. 2 divided by 0.5. You will find the number of boxes. See, 4 small boxes to be taken. So 1 minus 3 comma 2. 1, 2, 3, 4 here. Okay. So 2 points have been plotted here. Third is minus 2.5 and 5.1. Minus 2.5 is clearly visible here. The task is 5.1. So how do we plot 5.1? So because 0.1 small box is 0.5, 2 boxes is 1 unit. So hence 2.5 comma 5.1. So 2 boxes 1 unit here, approximately here. Yes. Okay. Then we are done with this thing. This thing minus 2 comma 6. X is minus 2. I think I made a mistake here. This was going to be 5.1 for here 2.5. 2.5. Okay. For 2 it is minus 2, it is going to be 6. So 6 is 5. I think 5.1 is going to be plotted on the 5 itself. Okay. So then 0.5, 5 and 6. On minus 2 we have to plot 6. Then minus 2 and 6 would be plotted here. Because 0.5 means if we take 2 boxes we are going to get 0.1. Minus 1.5 here and 5.4. So 5.4, that is 5.4 here, because this small box is 0.5. So if we're taking 5 plus 5.4 means 5 plus 0.4. So 0.4 should be little less than first box. Okay, and we're done with this. Minus 1 and 4. Minus 1 and 4. 4 means this is 2.5. This is 4. Okay, you need to count the number of boxes every time. So 0 minus 0.5, 2.6. 5 positive 2.6. So this is 2.5. This is 2.5 and 2.6 is here, because every small box represents 0.5 units. And next is 0, 2, 2, 2, 2. 2 means 4 boxes, 1, 2, 3 and 4. Okay, we took the 4 boxes. And next 0.5, 2.9. This is 0.5 here, clearly visible. 2.9, 2.9 means this is 2.5, this is 2.6, this is 2.5, 2.6, this point is, let us assume this point is half of 5, 2.5, and this is 3, and we have to plot what? We have to plot 2.9. So 2.53, this would be approximately on 3, and let us draw this here. Okay, the next point is 1, 6. So this is 1 and 6 is, this is 5 and 2 boxes above 5 here. So we are going to get 6 here. And the last point, this is 1.5 comma 12.1. Okay, this last thing, 1.5 and 12.1. So 1.5 is at the end of the graph and 12.1. So this is 10, this is 11, this is 12, and approximately here. So this is the graph which we can plot here, and let us try to plot it. Okay, fair enough. We have drawn the graph, and you need to take care very much of the scales. These are very important. Okay. Now we have drawn the graph, and we got 4 marks here. So hence this is 3, this is 4. We got 7 till now. Let us move further. Use your graph to solve the equation x cube plus 3x square plus 2 equals to 0 at from minus 3.5 and to 1.5. So let us, we have to solve this equation, and first of all we need to copy the function y equal to x cube plus 3x square plus 2, y equals to x cube plus 3x square plus 2. So whenever you will be having to find the equations to solve, you need to copy the function and check what is the left hand side of the equation and what is the function. So they are same. They are same, it means this value can be captured as y equals to 0. So we have to go to the graph and find out y equal to 0 where it cuts the graph of the given function. So y equal to 0 means it is a horizontal line. At 0 means it is itself equation of x-axis. So if you see carefully, we have not been asked to draw y equal to 0, hence we are not going to draw it. We have to solve the equation. If you see x-axis here, this is the equation of y equals to 0 itself. It is intersecting the graph here. So it is intersecting the graph here. So hence we need to find the x value here. So x value is minus 3, minus 3.1, minus 3.2. It lies between minus 3. Minus 3.15. So according to me, this should be minus 3.15 because it lies between 1 and 2. 3.15. So hence the solution should be minus 3.15. So hence we have found the solution at y equal to 0. So that is a fundamental idea. The left hand side of the equation, this thing, should be identical to the given function. If it is not identical, you need to make a little modification here. So make this identical to the function itself. Okay, so we are done with that. Now let us move further. By drawing the suitable straight line, solve the equation. There is one more equation to solve. Okay, let us see. We are having the function here, and what is the gap between these two? So we need to change this. Okay, function will remain as it is. So what is x cube? We have been matched, that is fine. 3x square, done. 2x, there is no 2x and there is no 2. 2 is done here. So what we are left here, we have extra plus 2x here. Okay, extra plus 2x. So what we need to do, subtract 2x both sides. So we need to make this identical to the given function. Okay, so what is going to happen here? X cube plus 3x square plus 2x minus 2x plus 2 equals to minus 2x. So these are two going to be cancelled, and the function is going to be identical to the given function, that is equals to minus 2x. So hence this whole thing will be taken as y. So y equals to minus 2x. We have to draw the graph of this thing. So since there is a one value of x is expected, it means the graph is going to cut the original graph at one point. So y equal to minus 2x. Let us draw this. Y equals to minus 2x. So what you need to do, draw a little table here and put some values of x and y here. X and y. So if I put x equals to 0, you get y equal to 0. If I put x equals to 1, you get y equals to minus 2. If I put x equals to minus 1, and you got y equals to minus 1 times minus 2, that is plus 2. So these are the 3 points which I had found here. If you do not want to do it manually, you can use your calculator and table function and put the starting and the end here. You will get the approximate value. Okay, fair enough. So 0 comma 0, let us draw this with different pen. Okay, 0 comma 0, that is the first point, and second is 1 comma minus 2, 1 comma minus 2. So x is 1 here and minus 2. Okay, so minus 2 means 4 small boxes because this is 0.5 for 1. So 1, 2, 3, 4. So this is the point here. Okay, this is the point. Sometimes we draw the sometimes we draw the cross, sometimes we can draw this point and the circle also. Anyway, anything you find it easy. And the third point is minus 1 comma 2, x minus 1 positive 2, minus 1 comma positive 2, that is not going to work here. 0 comma 0, x is 1, y is minus 2, x is minus 1. So 0, 0, 1 comma minus 2. 1 comma minus 2 will go downside. Okay, sorry, my mistake. 1, 2, 3, 4 here. Okay, and the third point is minus 1 comma 2. Minus 1 comma 2, 1, 2, 3, 4. Okay, we have found 3 points. That is the benefit of finding 3 points. When you plot these 3 points, if they occur in a straight line, it means your graph is correct. So hence now I'm going to draw. Okay, let us take this line to the given points and it will overlap. Okay, fair enough. So this is the graph of y equals to minus 2x. If you write the equation here, it would be easy for the teacher to understand what is happening here. So I have drawn here and it is cutting the x graph at this point. And what is the x here? The x here at minus 2.5. So hence the solution for the graph of this equation is minus 2.5. Now the next thing is, for this function, the equation this and that has three solutions. K is an integer. So what is happening here? See carefully. X cube plus 3x square plus 2 equals to k. Okay, so they say that the graph, if you draw the graph, then we'll be having three solutions and every solution is a value of integer. And let us see what is happening here. So this is identical to the given function. So hence we can write it as, we write these value as y equals to k. So since k is an integer, it means y can be 0, y can be 1, y can be 2, y can be 3. But we have been given the condition that we should be having three solutions. So let us go to the graph. Y equal to something. The other thing is y equal to something is a horizontal line. Okay, so we have to understand which horizontal line cuts the graph at 3 points and how many lines are possible. Let us see integral values. If you see, the graph is going to cut from here itself. Okay, so the equation can be like, the first thing is, if you take 5 and after that we may be having this point is this is 1 and this is 2. This is 1, this is 2. Okay, so this value goes to 2. So we are having here, the answer is going to be 3, 4 and 5, because if you see, this is the turning point here is, if you're trying to find, let me draw this. This is approximate turning point here. If I try to put it, this is 5 and this is 2. So if you see the graph of 5, it is cutting at the graph at 1, 2 and 3 points, and 2 doesn't satisfy our condition because it is not intersecting the graph at 2 points. Then what are the integers which are between 2 and 5? That is 4 and 3. So hence 5 will be cutting, y equal to 5 will be cutting the graph at 3 points, y equal to 4 will be cutting the graph at 3 points, and y equal to 3 will be cutting the graph at 3 points. And the answer is going to be either k can be having values, k can be having the values 3, 4 or 5. So if we are having y equal to 3, then the equation will be having 3 solutions, and y equal to 4, the equation would be having 3 solutions, and y equal to 5, the equation is going to have 3 solutions. Okay, let us see one more problem here. Okay, so we are having a graph. This question had been asked in 2019. You need to see the question number here. Okay, so we are having a function here and we need to complete the table first. So this is 0.2. See, the first value is 0.2, then 1, 2 and 3. So what we need to do, find the value 0.2 manually, and then we will be substituting using the table. Or if you want to put the values, it is your wish. I'm very much convenient with the calculator. Okay, let us go to the calculator. The function is function table. This is 7, and the function is y equals to fraction. This is 1 over 2x. Fair enough. X comes out with alpha and this bracket, okay, and minus again fraction. This is x alpha and this thing upon 4. So we have to find here what is the function. Then we need to put the values equals to, and start at 1 and it ends at, its end at 2. Step is 1, and what are the values here? For 1 it is 0.25, and for 2 it is minus 0.25, and rest we have to calculate. So okay, so now what do we have to plug in the value 0.2 here? 0.2. To start with 0.2, and let us assume end with 0.4. Put an imaginary value. I need to find only 0.2 and 0.4, and step is 0.2, and at 0.2 we got 2.45. 2.45. Okay, fair enough. That is correct. So we got all the values. Table is completed. We got 3 marks for this table. And let us move further on the grid. Draw the graph, and last 2 points have been plotted for you. So here the 2 points have been plotted. See carefully, it's a long graph. 2 points have been plotted here. So you need to take the divisions under consideration. This 1 unit is divided into 20 parts. It means here on x-axis, one small box is equals to 0.0. 0.05. Okay, here the one box is again divided into 20 parts. So the small box is 0.05 unit. That is a scale, and let us move further. So first point is 0.15, 0.15, 0.15 and 3.3. X is 0.15, Y is 3.3. X is 0.15. 0.15 means on X the scale is 0.5 and you need to take 1, 2, 3 boxes. So this is 0.15. 0.15. And Y is, the Y we need to take as 3.3. 3.3, it means 0.5 times 6. So it comes out to be 0.3. It means we need to take 6 box of 3. So this is going to be here approximately. So here let me make it a little smaller. Okay. So we have to raise this point. If I get a straight line, come on. This is first, second, third point. Third point on here. 1, 2, 3. So we got the first point here. 3.3. Second is 0.2, 2.45. 0.2, it means we have to move 1 point further. Fourth box here. Okay, fourth box. And what is 2.45? 2.45 means 2 is 2, 4.45 divided by 0.9. So what we are going to have, 2, 10 by 9, this is going to be 9 tens are 4.5 boxes. So approximately 4.5 boxes. This is 2.45. We have to go here, this thing, and fourth box, 3, 4. So we have to count 4 box. Okay, 1, 2, 3, 4. Okay, done. So this is also done. Next is, let me mark a tick here, 0.5 and 0.88. X is 0.5, fair enough, this line, and 0.88 means 0.88. So you need to use a calculator. This is very simple if you find the fundamental. So you need to point 0.88 and one box is 0.05. If you divide it, you will get number of boxes 17.6. So this is 10, this is 20, this is 15. Okay, this is 15 and you need to take 17.6. So 15, 16, 17 approximately here. So what is the X point here? 0.5 and 17 boxes. 15, 16, 17 and approximately here. Okay, so we plotted the second, third point, this point, this point, this point, and next is 1 and 2.5, 0.25. 1 is here and 0.25 means exactly midpoint. Okay, now further 1.5 and minus 0.4. 1.5 and 0 minus 0.4. So minus 0.4 means approximately 1 box down we got here. Okay, this thing, 2, x is 2, y is minus 0.25. Minus 0.25 because 0.05 is 1 box. If we multiply by 5, we get 0.25. So 5 box down. This is 2 and minus 0.25. So 1, 2, 3, 4, 5. So we get the cross here. and let us delete this. So we're done with this, and my 2.5 minus 0.43, 2.5 here, and 0.43 minus, if you divide by 0.05, you're going to get approximately 8.5 boxes. So 8.5 boxes. So this is 5, 6, 7, 8, and approximately here. So I'll put the cross here and let us delete this. Okay, and we're done with this. 3 minus 0. Last 2 points have been plotted here. Okay, so we got the things here, and now let us make it small and connect all the points. So graph should be a little smoother. Graph should be smoother, okay? Okay, approximately this thing. Okay, so it took a lot of time. Okay, fair enough. The graph is done. Use your graph to solve the equation this and that. So first of all, we need to copy the function 1 by 2x minus x by 4. The function is 1 by 2x minus x by 4, minus x by 4. And let us see the equation here. In the left hand side is exactly identical to the function, so we can let this part as y equals to half. So y equal to half is what? That is a horizontal line. Okay, let us see how y equal to half behaves here. So y equals to half is a horizontal line, so hence we are going to draw a horizontal line here. Y equals to 1 by 2 is y equals to 0.5, both are the same things. So we got here, and now we have to calculate where it cuts the x-axis. Okay, here, and let us go down this point. So how many boxes? This is 10, this is 15, 16 and 17. It is going to be 0.85, because 17 times 0.05, it is 0.85. It means our answer of this problem should be 0.85. So 0.85 is the answer of this problem. And on the grid, draw a line y equal to minus 2x. Write down the x coordinates of the points where the line crosses the graph, this and that, and blah blah. Okay, so y equals to minus 2 minus x. So we are having equation y equals to 2 minus x. We have to put 3 different values for x and y. Okay, so let us see x and y. If we put x equals to 1, what is the value of y? Y is going to be 1. So 1 and 1. If we take x equals to 2, then 2 minus 2 is 0. So hence y will be 0. And if we put x equals to, let us assume minus 1, then y is going to be minus 1, minus plus, y equals to 3. So minus 1 and 3. So we got 3 different points here for y equals to 2 minus x, and let us plot these points. 1, 1. So x is 1, y is 1. The first thing is 1 and 1. It is plotted. Second is 2 comma 0. So x2, 2 comma 0. Third point is minus 1 and 3. X is minus 1. We do not have a negative thing here, so hence we need to remove this. We put x equals to, let us assume 3 here. x equals to 3, then y will be getting 2 minus 3 is minus 1. So let us leave this 3 and minus 1. Okay, so x3, y minus 1. 3 and minus 1 will go here in the down, and let us draw this. Okay, we plotted all 3 points. Now we have to complete the graph. Okay, so here is the graph of y equals to 2 minus x. And what is the question here? Let us see. Write down the coordinates, the point where the line y equals to minus 2x. Which coordinates we have to write? See carefully. We have to write the x coordinates. So this is the same thing to solve. So we need to find the x coordinates here. Okay, this thing. So count the boxes here. This is 1, 2, 3, 4, 5, 6, 7, 8. It means it is going to be 0.4. And on the other hand, here what we are having, x equal to this is 2. Here this intersects here. So how many points are there? This is 2 plus 8 boxes, 2.4. So this is going to be x equals to 2.4. So we are having 2 points, x equal to 0.4 and x equals to 2.4. X equals to 0.4, x equals to 2.4. So that is the solution. Okay. So now next thing, solve the second E part. What we'll see here, we need to find that the graph is useful to find the value of root 2. So it means the value of root 2 is somewhere involved in this function. So how do we can find that? Let us substitute x equals to root 2 in the function. Let us hope what happens here. That is 2 times root 2 minus root 2 by 4. So here we need to do rationalization because we have denominator in the root. So root 2 by root 2 minus root 2 by 4. So over root 2, in the denominator we are having root 2 into root 2, 2 times 2 minus root 2 by 4. This comes out to be 0. It means when x is equal to root 2, y is becoming 0. It means when x equals to root 2, y becoming 0. So it means when x is becoming root 2, y is becoming 0. So if you see on the graph, y equals to 0, x equals to root 2. So where the graph is intersecting, see carefully, because we have identified here that on y equal to 0, where the graph cuts, on y equal to 0, where the graphs are intersecting. So on y equals to 0, this is y equals to 0, the graph is intersecting approximately here at this point. So this point is approximately 1.4. So hence we can say from the graph, we can say that from the graph at y equal to 0, we could find root 2 equals to 1.4. So that is whole about the problem, and let us see the next one.